I would like to invite our first panelist to the stage from the University of Toronto, a doctoral student in chemistry, Emily Majaesic. Emily's talk is called Cathoprotein by its Tail. Welcome, Emily.
In the summer of 1990, my Uncle Ron had just started his career and his family. That July, he was rushed to the emergency room, and 2 days later, he died of leukemia. For many diseases, including leukemia, early detection plays a huge role in your chance of survival. Often there are things that could have been done, but by the time you know the disease is there, it's too late. My research aims to make a new type of technology, one that will be able to warn doctors when disease is coming. The way this technology will do this is by detecting subtle changes in the levels of your proteins. Now, I know most people think of proteins as soy or chicken, but for today, I need you to think of proteins as the tiny machines that keep you running. There are thousands of different types of these tiny protein machines, and when your body is attacked by a disease, the amount of each type changes. So a person with Alzheimer's might have too many copies of proteins A, B, and C, while a person with leukemia might have too many copies of protein X and Y. I am making a detector that is sensitive enough to tell when your levels are starting to drift ever so slightly, maybe even months before you develop symptoms. To do this, my detector needs to identify individual copies of proteins so that it can count them. I'm starting by copycatting the technology that identifies DNA. That's the red side of my slide. That detector works by threading a string of DNA through a tiny hole. As each rung passes through the hole one by one, the detector reads them out. In theory, we could use this same detector to read and identify proteins, but there's one problem. Protein strings fold up like a tangled ball of yarn, and those can't be threaded through the hole. How I'm fixing this is shown on the blue side. I'm adding an extra piece, a detangler, that will grab the tail of the folded protein and unravel it before sending it through the detector. If this technology had existed in 1990, a regular checkup could have told us that my uncle's levels of protein X and Y were a little bit elevated, and maybe we would have known he was about to develop leukemia. I wonder what would have been done differently if we had known. I wonder how different my cousins' lives could have been. But the thing is, this technology, it's not just for leukemia, but for nearly any disease, because they all affect your protein levels. What I'm trying to do here is create the tools we need so that in the future, we can prevent disease rather than just treat disease. And I'm so grateful to have the opportunity to work on bringing us into that future every single day. Thanks.